In figure 1a and 1b, we observe that either albumin and serum undergo aggregation upon copper exposure. However, in the case of albumin, the aggregation does not take place at concentrations of copper lower than 0.3 millimolar, while in the case of serum it does. In figure 1c and 1d, we observe that the aggregation in albumin and in serum is dependent on copper content but not on protein concentration. Interestingly, when we separate the pellet from supernatant and we determine the protein content by Lowry, we confirm the previous result, but we also see that in the case of serum, there are proteins that precipitate at very low concentrations of copper, like lower than 200 micromolar. Also, the highest concentrations of copper we used previously do not fully precipitate the serum, which indicates that blood has proteins that show higher sensitivity to copper-induced aggregation and lower sensitivity to copper-induced aggregation than albumin. In figure 3a, we see the SDS page of proteins from serum exposed to two different concentrations of copper, 200 micromolar and 800 micromolar. What we observe is that when we go to the lower concentrations of copper ions, the fractions are enriched in high molecular weight proteins. In figure 3b, what we observe is the proteinogram of the pellet and the supernatant of the proteins exposed to these two concentrations of copper. In the case of the lane that was run for the pellet exposed to the 200 micromolar of copper ions, we observe an enrichment in the gamma fraction. As a conclusion, we can say that copper-induced protein aggregation is dependent on metal concentration rather than protein concentration. Also, the aggregation induced by this metal is protein-specific, suggesting that certain proteins present in blood might be more sensitive to mild increases in the free copper ions concentration in circulation. Also, gamma globulin seem to be among the copper-induced aggregation-sensitive proteins. Due to their protein concentration in blood, these proteins and their interaction with copper ions could be relevant in the physiopathology of copper imbalance-related disorders.